Assalamu alaikum students, this is solution of the quiz we held about kinematics. So I start from question number 1. The statement is a ball is dropped from a tabletop. Air resistance may be ignored. So there is no resistance, so no terminal velocity. Which rule describes the velocity acceleration of the ball at point x? And as this in this question, air resistance is 0, or we have ignored the air resistance, so it means acceleration should remain constant. So initial value of the acceleration is 10, so it will remain constant throughout the journey, or throughout it falling towards the earth. So acceleration remains constant, but as acceleration means change in velocity, increase in velocity, so velocity will keep increasing. So that is why option B is correct. Acceleration constant and velocity increasing. Okay, next. The diagram shows the speed time graph of a car. Which area represents the distance traveled while the car is accelerating? As this is a speed time graph, so if the car is accelerating, we have a straight line that will has some constant gradient or positive gradient. So this portion has positive gradient and this portion has gradient equal to 0. It means here speed is increasing with the constant rate. It means it is accelerating at x. So the area under this will give you the distance traveled by the car while accelerating. So X option is correct. So that is why I've chosen A. Next, in a lab, a ball is dropped in a vacuum and falls 200 centimeter. Now you can see initially the distance was 0, then 50, 100, 150 and 200 centimeters. This statement describes acceleration of the body. It is greater at 10 and then at 200. It is greater at 200. It's smaller, the same value at 50 as at 150. So we assume that as it is vacuum, there is no air resistance, so acceleration remains constant. So that is why option D is correct here. All right. Next question. A man stands by a railway track. You can see this railway track and the train, and this man is standing. A train traveling 40 meter per second takes 2 seconds to pass the man. So speed has been given and it is actually a distance. Oh, sorry, time. What is the length of the train? So length of the train means we have to find the distance. We know that distance is equal to speed multiplied by time. So if multiply 40 multiplied by 2 gives you 80 meters. So that is why option D is correct. 40 multiplied by 2 is 80. Next, the speed time graph represents the motion of a car traveling along a straight level road. Which statement describes the motion of the car? You can see the speed is increasing, but the gradient of this graph is decreasing to 0. That is why the acceleration is because acceleration is actually the gradient of speed time graph. So gradient is decreasing means acceleration decreasing. So it accelerates and reaches a constant speed. It accelerates and stop moving. It decelerate. It accelerate initially, and then when the acceleration is 0, it gets this, it attains the constant speed. So that is why option A is correct. Next question. An athlete runs 300 meter up a hill at a steady speed of 3 meter per second. She then immediately runs the same distance down the hill at a speed of 6 meters. So this is up speed and this is down speed. What is her average speed for the 600-meter run? So we know that average speed is equal to total distance over total time. So we need to find the time for upward journey and then downward. So how to get the time? Time is equal to distance over speed. So from here, time is equal to distance over speed. and distance is 300 meters, whereas speed is 3. So the time we get is 100 seconds. And what about here when the body, when athlete is going downward, distance is same, which is 300, but the speed changes. Now speed is 6. So time will be 300 over 6 gives you 50 seconds. So this is a time, 100 seconds plus 50, this is total time. So average speed will be equal to total time, total distance. Total distance is 600, 300 plus 300. And total time is 100 plus 50, 150. So average speed will be equal to 4 meter per second. So that is why option C is correct. Okay, clear this and then moving to the next question. Okay, next question. The graphs represent the movement of a body accelerating from rest. After 5 seconds, how far has the body moved? So again, we have to find the distance. Distance is equal to area under the graph of speed, under the speed time graph. So area under the graph means this is a triangle. So we know that triangle area is 1 over 2 base into height. Here, base is what? 5 seconds, whereas height is 10 seconds. So calculate this value, it gives you 25 meters distance. So during this interval, the car travels 25 meters. So that is why option C is correct. Okay, clear it? Next question. The graph shows the progress of an athlete in a 100-meter race. Which time was taken to travel 10 meters from the start? 10 meters from the start. So where is 10? So we have to find the 10 is here. 1, 2, 3, 4, 5. This is 10 meter. And it is clearly 2.8. You can see this value is 2.8 seconds. That is why option B is correct. So option B is correct. Okay, next question. Two stones of different weights fall at the same time for a table. Air resistance may be ignored. What will happen? Air resistance, there is no air resistance means the time for both of the bodies will be same. Time of falling will be same because gravity is acting. So both stones hit the floor at the same time. Option A or B. Why the acceleration of free fall is constant? They fall at a constant speed. No. The acceleration of free fall is constant. So option A is correct here. Next question. A car travels 100 kilometers. The highest speed for the car is 90 kilometer per hour and the lowest speed is 30 kilometer per hour. The journey takes 2 hours. So what is the average speed for the journey? Highest speed is 90 kilometer. Actually, average speed doesn't depend on highest or minimum speed. It depends on the total distance covered, which is 100 kilometers. as we need to find the answer kilometer per hour. So this value should be in kilometers. And how many hours the journey takes? 2 hours. So 100 over 10 gives you 50 kilometer per hour. So average speed doesn't depend on how the doesn't depend on the highest speed of the car or low speed of the car. So option B is correct here. All right, next section. So let's clear this. Okay, so this section has theory questions. So question number one is, figure 1.1 shows how the speed of a car varies over a short time. So you can see the total story of the car traveling. This is speed time graph. Different parts of the journey are labeled A. This is A, then B, C, D, and E. The different intervals are represented by the letters A, B, C, D, and E. Straight a part of the graph that shows the car at rest. So you can see here at A, the car speed is 0 because rest means speed is 0. Similarly, in this part E, 28 to 32 seconds. In this interval, the car speed is 0 as well. So you can write A or E, any one of them. Next, straight a part of the graph that shows the car moving with constant speed. Constant speed where the speed is not changing. So this is the part C. You can see in the figure. Next question. Next part, sorry. During part of the journey, car decelerates. Decelerates means speed is decreasing. Calculate the distance traveled by the car when it is decelerating. So decelerating is here because in interval D, the car speed is slowing down or car speed is decreasing. So if we calculate this, this is actually a distance. So distance is equal to area under the graph, which is 1 over 2, because it is a right angle triangle, so it will be 1 over 2 base multiplied by height. So 1 over 2, what is the base? Base is 4. Sorry, base is 8. And height is 16. So you calculate it, it will give you 64 meters. So this is the process you were supposed to write. First, distance formula, and then insert the values and then find the final value. All right. Next, uh, another car accelerates from rest starting at 0 seconds. This car has a constant acceleration. Constant acceleration, it will have a straight line graph. Its speed is 20 seconds in 10 meter per second. Sorry, its speed at 20 seconds is 10 meter per second. On figure 1.1, draw a line to show this motion. So you go to the figure 1.1. At 20, the speed was 10. So just you have to use the line at 20. This is 20 and the speed will be 10. Just this line. You were supposed to draw this line. So this is your answer of that part. Okay, I'm clearing this. Now moving to the next question. Question number 2. Figure 1.1 shows the axis used to plot distance time graphs. So this is distance time graph. On figure 1.1, draw a graph of an object that is moving with constant speed, labeling the graph A. So you have to label as well. Constant speed means because the gradient of distance time graph gives you the speed. So this distance time graph should have a straight line. because the gradient is constant. So suppose this is A, to label it. Okay, part 1 done. Part 2, moving with decreasing speed. Decreasing speed means the gradient becomes 0 or decreasing. So I'm making another graph. So this one is decreasing. You can see here the gradient is decreasing. This is B. So this part has been done as well. Clearing this drawing and moving to the next part. The next part. Figure 1.2 shows the axis used to plot speed time graphs. All right. Number part 1, moving with constant acceleration, labeling the graph as. So you have to draw this graph. Moving with constant acceleration means speed time graph, and we know that the gradient of speed time graph gives you the acceleration. So you should draw a straight line again. So this will be a graph of a body that is moving with constant acceleration. So you have to label as well. Label with S. Next part, moving with increasing acceleration. Increasing acceleration is what? Means gradient is increasing. So I'm using this one. So now you can see here this gradient is increasing. So label is with T letter. So I've labeled as well. Okay, so I'm clearing this and again moving to the next question. Question number 2. Another question. There is no atmosphere on the moon. An astronaut on the moon drops a feather and a hammer from same height at the same time. So no atmosphere means there is no air resistance. So actually astronaut is dropping a feather. You know that feather has very less weight, and the second body is hammer that he is dropping. They both accelerates downward at 1.6 meter per second. Obviously there is no air resistance, so acceleration will be constant for both of the bodies, and they hit the ground at the same time. Obviously they should hit. The weight of the hammer is much larger than of the feather, and you know that. Explain in terms of their weights and masses why their accelerations are equal. So in this question you have to write first that weight depends on the mass, because we know that weight is equal to mass into gravitational field strength. Gravitational field strength is 1.6. So whatever the mass is, weight will be respective of this. Clear? So if the mass is lower, the weight will be lower. It means, and if the mass is higher, the weight will be higher. It means if the mass is lower, the force of gravity that exerted by the moon is lower, and if the weight is mass is higher, the weight will be higher. It means the force of gravity that exerted by the moon on the body is higher. So if a feather, suppose this is feather and this one is a hammer. This is moving actually downward because of the gravity. So this body, this feather will experience less force of gravity, whereas this hammer will experience a greater force of gravity. Because of this, W is equal to mg, as mass is lesser and here mass is greater. So actually you have to write, you should have written that weight depends on mass. Another thing you have to write, I'm showing the marking scheme of this. Wait a minute. This thing, weight is directly proportional to mass. Number one mark. A larger force acts on the more massive body. मैं यही बता चुका हूँ आपको, ठीक है ना? I have told this. W is equal to mg. Second number, so mass cancel or acceleration inversely proportional to mass. Acceleration is inversely proportional to the mass. So right here, wait. Acceleration is inversely proportional to mass. This is Newton's second law of motion. So it means greater the mass, lesser will be the acceleration. So that is why they both have the same time, uh, time of falling. Because lower body has less acceleration and higher body has a greater acceleration for this because of the resultant force. So that is why this question had 3 marks, and you should have written these 3 things to attain all full marks. All right, this is end of the paper. So you're supposed to submit it when you have done this one. Okay, Allah Hafiz.